Welcome back. Let's continue our discussion on transforming line structures to Fischer projection. I'm sure many of you are thinking, could you have done one more problem? It would make life easier. And that's exactly what I'm going to do now. Okay, so let's get in and do this. So here's the compound. So as always, first start assigning numbers. Now, like I said, it doesn't matter if you start from left to right or right to left. But for being consistent with what I teach, I'm going to go from left to right. So this will be 1, 2, 3, 4, and 5. That means I have 5 pivot points on my spinal cord that I'm going to draw. Right? That's the first step. Second step is just you go about business doing RNS. And clearly, there's only 2 chiral carbons here because it's usually the ones indicated by the open and closed wedges. Now, if you remember from 330, if nothing is given, assume it's hydrogen. Okay, so I'm going to draw hydrogen here. That's not a typo. I purposefully left it there just to see if you caught it up. All right, so that's that, and let's put the picture up on screen. So this is 1, and again, same business. This is attached to C. This is attached to C as well. This is attached to 2O, but it is attached to a double bond O, so that takes precedence. So that's 2 and 3 and 4. Now, again, like I said, these 2 examples have specifically included it this way. This may never ever be a problem on many other examples you might do. So this is 1, 2, 3. It's counterclockwise, and it's in a back position. So counterclockwise back is S. So this right here is S. Second, 1, and this is 4 as always. And life is easier here because there's not even a doubt whether this is 2 or 3. This is 2, and this is 3. So that's 1, 2, 3. That's clockwise and back. And clockwise back, we all know, is R. So we've done 2 things. We've assigned numbers to figure out how many carbons that we have for our pivot points on our spinal cord, and then we have determined the RNS for the line structure. So let's go ahead and draw our pivot points. 1, 2, 3, 4, and 5. This time I'm not going to mess around. I'm just going to draw only connecting the dots. This way I don't have that excess line like I had last time. And I like to keep things clean as much as possible. So this is 1. This is the carbon. If you want, write the carbon just to make your life easy. This is attached to 2 OHs. Okay. Doesn't have to be perfect. Just draw the 2 OHs on that carbon. That's what it really is. And then you draw 1 flat line, and then see, this is not a chiral, so you cannot really draw a complete flat line. You just have to draw C, double bond O, because it's not chiral. Only for chiral you can draw a full flat line. This is chiral again, and this is C, which is CH2, and this is attached to a OH. Right? Remember, any bend is a CH2. This is CH2. Now, as I said, it doesn't matter whether hydrogen is in front or back, or whether it's to the left or right. It doesn't matter. Just put the hydrogen on this side and the Br on this side. Similarly, whether it's front or back, doesn't matter. Just put the H here and Cl here. Okay? Because that's the way I'm going. I'm going 1 through 5, right? So this is my 1, 2, 3rd carbon, 4th carbon, and 5th carbon, right? Now let's go ahead and assign RNS and see if we have to do any flips at all. So this is 1, clearly this is 2, this is 3, this is 4, and like I said, for convenience, assume this hydrogen is in the front. So it's 1, 2, 3, that's clockwise, and front, clockwise front is 9. I mean, sometimes it matches perfectly, sometimes it doesn't. Clockwise front is S. That means we do not have to mess around with this part. Let's finish it and then go back and draw if we have to make any changes at all. Okay? Again, keep this as friend. Okay, so this is 1. Clearly this is 2. This is 3, and that's 4. So that's again, that's counterclockwise and friend. That's R, I think. Perfect. That means we match this S and R to this S and R. So we do not have to flip anything. We can go ahead and rewrite this one more time exactly the way it appears. That means, see, that's the beauty about chemistry. You know, things are easy. So this time, just draw a flat line. You do not have to change anything. Continue your pivot points. This is C double bond O. Continue again flat line, HCl. And then again, wrap it up. And that's your Fischer projection. So the way we drew it was exactly the way we finished. Sure, done. All right, so that means I got a practice for you. So when you do your thoughts for this series of videos, this is what you turn it in. The rest of it is just for knowledge. And I will see you with going from Fischer to line. Okay, that's exactly opposite of every step we just did. We're just working backwards. Okay, so work on this practice, and then if you have any questions, ask me. Before I wrap it up, you may be wondering, is it CH3 or H? Well, as I said, if it's not given, assume it's H, so I'm just going to leave it. So just to eliminate any controversies that some of you might have, just assume these are hydrogens. Okay. All right, well, that concludes it. We're done, and I will see you with another video.